In this video we're going to discuss Gauss's law and look at some of the practice questions on this topic. So just as a reminder going into this lesson, you need to know the area of a sphere, the volume of a sphere, epsilon naught, and the charge of an electron. So Gauss's law, this is the rule that we were given. Flux equals E multiplied by A. Or you can say instead of E, we can bring in the formula K equals Q over R squared from before when we did about the electric field of a charge. A, we can bring out the area of a circle, or I should say the area of a sphere, the surface area. Because what's happening is you will have a charge and he has an electric field going out in all directions, and you can draw a little sphere around it. That is where this E comes from and where the A comes from. Great. So essentially you'll end up with this rule here, 1 over 4 pi epsilon naught multiplied by Q over R squared, because instead of K, we're going to substitute that inside. Multiply that by 4 pi R squared. We can do some cancellations. The 4 pi and the 4 pi can go. The R squared and the R squared can go. And that leaves us with simply flux equals Q over epsilon naught. So we went from EA into Q over epsilon naught. Amazing. Okay, so that takes us to the full Gauss's law formula. It says the flux through any closed surface is the same as whatever the charge is enclosed over epsilon naught. So it's the charge that makes the difference. So if I take a ball or a cube or anything and I place some sort of charge in here, this is my charge, and he will have, let's say it's a positive charge, so the field lines will be going out the way. It's going to be going out like this. And if I increase the charge, if I make it bigger, add more electrons or more protons, whatever I do, I will end up having more lines, which means that my flux is increasing more. Yes? Easy peasy. If you don't have it that way, you can still use the classic way, EA, from before, from the flux. Okay, this is useful for symmetrical objects when you're trying to quickly establish the flux. For example, if you take a big ball like this, and you have a bunch of charges inside the ball, you can figure out what the overall flux will be simply by adding and subtracting these. So for part A, which is the big ball, we add them all. So it's plus 2 minus Q plus Q. So what's going to happen there? So that will be plus 2 minus 1, so that will be positive 1, and then that will be taking you back up to positive 2. That's what we did over here. And you can do the same thing for the second one. You can find the total charge going through B. I can look at B here, which is this one. We can see that it's plus 2 minus Q. That is positive 1, so that's 1Q. C, same thing. Look at that. It's plus Q and minus Q. That becomes 0. They will cancel each other out. So the charges in here, plus and a minus, will cancel. D, which is the last one, which is this one here, that only has a negative Q, so that'll be minus. If you wanted to find the flux, we can just use Q over epsilon naught. So remember for A, we figured out the total, it was plus 2Q, right? So what we can do is we can put that into the formula. We can say flux equals Q over epsilon naught. What we did was it becomes 2Q because there's 2 of them. Overall, you add up, it becomes 2Q. So it'll be 2 times whatever Q is. 1 times 1.6 times 10 to the minus 19. And I'll divide that by epsilon naught and you'll get a number. You do the exact same thing with B. B, we decided that it is plus 2 minus 1. That is just Q only. So I'll write Q over epsilon naught. Put 1.6 in here and I'll divide by 8.85 and you will get your answer. For C, we established that it was 0 because it is minus and a positive. They cancelled. For D, we realize that D only has 1. This part here, this is D. It only has negative Q inside it. So we will put negative Q over epsilon naught. Same way, minus 1.6 times 10 to the minus 19 divided by 8.85 times 10 to the minus 12. And you will get your answer. Okay. The next thing in this lesson was about density. Density is how close the charges are. So there are 3 different types. We will have 3D shape, a 2D shape, and a 1D shape. You will have a volume, okay, like a sphere, for example, which will be rho equals Q over V. This is density, is charge over volume. Before you knew it as mass per volume, now we have it as charge per volume, because this is charge density. That is for like a 3D shape, yeah, something 3D, which is why we need to know the volume of a sphere, for example. Okay, another one would be the surface charge density, which could be just like a simple sheet of paper, which is only the surface on it. That was Q over the area, whatever the area is. If it's a circle, then it will be the area of a circle. If it's a square, it's the area of a square, length times length. Finally, it will be a linear charge density, which just means a straight line. You'll take a wire, like a straight wire, and you will find the length of the line. It will be Q over L. So you have charges dotted across here. You'll have charges dotted across here, and across here. Not this one, he's outside. These ones here, and these ones here. Okay. You can also find the total charge looking like this. You can say Q total is the integral of the density times by the volume. All we did was we took this and we rearranged the formula and to make it look like this. Okay, this is if you're given a function, you can integrate using it. Another example of finding out the volume charge, surface charge, and linear charge. I did this with you in class. If you wanted to use a cube with these lengths, so we know the sides are all 4 centimeters each, and the only thing is centimeters. So you have to divide by 100. So it'll be 0.04 meters multiplied by 0.04 meters multiplied by 0.404 meters. That's how you find the volume of a cube. Yeah, 0.4 cubed, hence the term, and that gives you this number here. Great, now I know the volume. If I know the volume, I can find the volume charge density. Density is charge over volume. What will the charge be? Whatever is inside. If I place one charge inside here, and then I can easily figure out the charge density. I could do 1.6 times 10 to the minus 19 divided by the volume that we just figured out right here. And you end up getting 2.5 times 10 to the minus 15. Okay. Density is coulombs per meter cubed, because this is a volume. So your unit will be C per meters cubed. And you can do the same thing for the surface charge density. This is just the area, so that's only one side, one surface, and that will be this side multiplied by that side, which is why we say 0.04 squared. Once you have that, you use the same formula. You will use the density equals charge divided by area, and you get the final answer. And it will be coulombs per meters squared, not cubed, because volume is cubed, area is squared. Linear charge density, same idea. You will just do the formula density equals charge, 1.6, divided by the line, which is 0.04. That's it. And then the unit will be coulombs per meter only, not squared, not cubed, because it's just a line. Easy.